All right, good afternoon, boys and girls. We're on lesson 80, prime and composite numbers. Our objective for today is to determine if a number is prime or composite, and also use arrays to represent prime and composite numbers. Here's our math joke for today. What do you get when you cross a calculator and a friend? And it's a friend you can definitely count on. Here's a vocab for today. The first one is array, which is a rectangular arrangement of numbers or symbols in columns and rows. And the second one is composite number. A composite number is a number with more than two factors. And a prime number are numbers with only two factors. Here's your new concept for today is a prime number. Everything highlighted here in green are considered prime numbers, meaning that they only have two factors. If we look here, 2 is the only even prime number, which makes it special. And it only has two factors, which is 2 and 1. 3 is also a prime number, which can only be divided by 3 and 1. And 4 is considered a composite number because it can be divided by 4, 2, and 1. All right, so that 2 times 2 equals 4. So therefore, because it has a 2 as a factor, it is considered a composite number. Now, 1 is not considered a prime number because it only has one factor, which is 1, and 0 is not considered a prime number either. Okay, so the first three prime numbers are 2, 3, and 5. What are the next three prime numbers? And what they do for you in the solution is they listed out just numbers after 5 and then figured out which ones were prime, and they crossed out all the ones that were not prime. Okay, so the three that are after 5 are 7, 11, and 13. Okay. Now, your first definition was array. Okay, so we can make arrays with numbers by using numbers, and so, for example, for the number 12, we can show the factors of 12 by doing 3 on this side and then 4 on this side, which is 3 times 4, right? And so this is our first array, and we have 12 shapes inside, 12 green rectangles or squares. And so an array has to, it's a rectangular shape. So if we had one missing here, that wouldn't be considered an array because it's missing part of it. You couldn't do that because it would be missing. Remember, it's a rectangular shape. Now, we can change the array because the number 12 has different factors. We could do one row of 12, right? And then we could also do 2 rows of 6. And it would still make an even rectangular shape. Now for the number 11, which is a prime number, there is only one type of array, right? Which is 1 across, okay, or 11 across. Now, for example, number 2, we're going to draw 3 different types of arrays for the number 16 and use different factors for each array. So what they're doing here is they have 16 can go 4 by 4, right? 4 times 4 equals 16. So we do 4 across and then 4 in each row. And then we can do 8 by 2. So they're drawing an array which is 8 across and then 2. And then we do 16 by 1. Okay, so there's 3 different ways to get 16. If you looked at 16 and find the factors of 16, we have 4 times 4 and then 8 times 2 and 16 times 1. And that's how you make and build your array. Okay. So that you're going to have to do that in your first lesson. In letter A, it says to use color tiles to mark different arrays for 14 and 19. What I want you guys to do is just draw the array using X's. Okay, so if you have 14, show me the different ways that you can get 14 by doing different arrays. And also on number 19, for number 19. So on your paper, you're going to draw X's in rows that look similar to this right here. Okay, so if you do 14 and 1, you just do 14 X's side by side. for letter A. Okay, and then letter B, same thing. You're going to draw two arrays for the composite number 9. And then C, you're going to list all the factors for 15 and 17. And make sure you read and answer all the questions, okay? See, we have different question marks. You're probably going to have to answer all those different question marks. So, if you have any questions, feel free to write those questions on the back, and we will speak about it tomorrow.